So the purpose of factoring is to solve polynomials. The purpose of the ultimate purpose of math is to find solutions to real life problems. And real life problems typically, they tend to be modeled using polynomials, exponentials, and all kinds of mathematical functions. So factoring is key to find a solution that we are looking for. So how do we find the solution to an equation, especially a polynomial equation? It all starts by writing the polynomial in terms of its factors. If we have it as factors, then we can easily find the solution. So here is a polynomial that is factored as 5x plus 1 multiplied by x minus 2 equals 0. Now, if you can't see it, 5x plus 1 times x minus 2 is 5x squared minus 10x plus x minus 2. I'm foiling, so I have 5x squared minus 9x minus 2. So what we have in the question is simply the factored version of the polynomial 5x squared minus 9x minus 2 equals 0. And we're trying to find a solution to that polynomial. So how do we go about doing this? Well, if a times b is equal to 0, then either a is 0, or b is 0, or both are 0. So where a and b are some numbers. So if I multiply two numbers and I end up getting 0 as the answer, then either one of them is 0 or both of them are 0. So here we have two factors. The first factor is 5x plus 1. The second factor is x minus 2. I multiply the two, I end up getting 0, which would imply, using the statement that I just wrote, 5x plus 1 would equal 0, or x minus 2 would equal 0. I'm setting each factor equal to 0, which would mean I can solve easily now. 5x would equal to negative 1, and x would equal to 2. So that is first solution. Divide by 5 on both sides, x is equal to negative 1 over 5. So the solutions to the equation are x is equal to minus 1 over 5 and x is equal to 2. If I took those values and plugged it in the equation, I am guaranteed to get 0 as the answer. So we have another factored version here, and we have an 8 up front. So that 8 doesn't mean anything because there is no x term. So to start, we're going to divide by 8 on both sides. Which would imply 3x minus 4 multiplied by 2x minus 7 would equal to 0 over 8. 0 over 8 is simply 0. Now I have two factors that are multiplied and they give me 0, which would mean 3x minus 4 equals 0, 2x minus 7 equals 0. Move the 4 to the other side, we have 3x is equal to 4, and x is equal to 4 over 3 if I divide by 3 on both sides. Here, on the right-hand side, I'm going to move the 7 to the other side, so I get 2x equals 7. Divide by 2 on both sides, x is equal to 7 over 2. So the solution, x is equal to 4 over 3, comma 7 over 2. People also tend to write it as a set. So you may see something written as 4 over 3, comma 7 over 2. Now, why did we learn about factoring? Well, the purpose is to solve a polynomial equation. So we have x squared plus 11x plus 24, and we would like to know if we can factor this easily. Well, how do we factor? You have to pick two numbers. If you add the two numbers, I must get 11. If I multiply the two numbers, I should get the product of the first and the last coefficient, which is 24. What two numbers could do that? Well, you may say, well, let me pick 6 and 5. Well, if you add, you get 11, but if you multiply, you get 30, but we need to have 24, so those two wouldn't work. You may say 7 and 4. If you add, you get 11, but if you multiply, you're not going to get 24, so that wouldn't work. 8 and 3. So 8 and 3, if I add, I will get 11. If I multiply, I will get 24. So that seems like a good candidate. So this is the factoring that we did previously. So I'm going to write the 11 as 8 plus 3. And now we can factor by grouping. So I can group the first two terms and the last two terms. I can see x in common in the first one. If I pull that out, I would have x plus 8. There is 3 in common in the last two terms, and if I pull that out, I have x. If I pull 3 out of 24, I would get 8. Now I have x plus 8 in common, and if I pull that out, from the first term, I leave behind x. From the second term, I leave behind 3, so I'd end up getting that. So I have factored it successfully. Now I just have to set each factor equal to 0. So which would mean x plus 8 equals 0 and x plus 3 equals 0, which would imply x is minus 8 and x is minus 3. So here we have 3 as a leading coefficient. Now that is trouble anytime we see that. So we have 3 times negative 14, which is negative 42, product of 3 and negative 14. So I have to come up with two numbers. So when I add them, I get, or I should get, negative 1. And when I multiply, I should get negative 42. That tells me one of the terms, one of the numbers has to be negative. So what all numbers could give me 42 as the product? There are very few numbers. Let's start small. 7 times 6 is 42. 21 times 2 is 42. 14 times 3 is 42. So we can't pick 14 times 3. Let's pick negative 7 and positive 6. If I multiply the two, I am going to get negative 42. If I add, I am going to get -1. Seems like I have my two numbers. So I'm going to write the equation as 3y squared plus -7 plus 6y, and that is going to correspond to the -1 we have there, minus 14 equals 0. So 3y squared minus 7y plus 6y minus 14 would equal to 0. Now we have grouped things successfully. So group 1, group 2. What do we have in common in the first two terms? We have y in common. So if I pull y out, I have 3y minus 7. We want to know what is common between 6 and 14. 2 is common, so if I pull 2 out of 6y, I would have 3y. If I pull 2 out of 14, I'll have 7. What is common between those two terms? We have 3y minus 7. If I pull 3y minus 7 out from the terms, we have y plus 2. So I have successfully factored the equation, and I end up having 3y minus 7 multiplied by y plus 2 equals 0. Now we just have to set each factor equal to 0. To solve for x, or y in this case, 3y minus 7 equals 0, and y plus 2 equals 0. So if I move the 7 to the other side, 3y would equal to 7. Divide by 3 on both sides. We have y equals 7 over 3. That is the first solution. Move 2 to the other side, we end up getting -2. So that would be the second solution. So here we have an equation where we have n times 2n minus 3 equals 2. I'm going to put a note here. Most common error. With the same process that we've done, if we use the same process that we've done in the previous problems and use it here, it is completely wrong. What do I mean by that? Students often tend to write it as, okay, right inside is just 0 in the previous problem, so we set each factor equal to 0. I have factors here, n is a factor, 2n minus 3 is a factor, so I could just set n equals 2 and 2n minus 3 equals 2 and solve. And that is completely wrong. We can only set each factor equals something if that something is 0. So the right-hand side has to be 0, which it is not in this case. So what do we do? So first we're going to FOIL, or not FOIL, distribute n inside. We have 2n squared minus 3n equals 2. Move the 2 to the other side, 2n squared minus 3n minus 2 equals 0. Now that looks like a trinomial and the right-hand side is 0. We can factor this and find a solution, and we can factor it by grouping. So we need to find two numbers so that when we add, we get -3, and when we multiply, we get -4. Well, there are only few numbers that would give us -4, which would be 1, 4, and 2 times 2. So clearly it can't be 2 times 2. So I'm going to say the two numbers are 4 and 1. So I could write that -3 as -4 plus 1 multiplied by n minus 2 equals 0, which would mean 2n squared minus 4n minus n minus 2 equals 0. Now we can group terms, 2n squared minus 4n. Going to pull a minus 1 out, which would give me n minus 2. Sorry, n plus 2. Negative pulled out of negative n is positive n, and negative pulled out of negative 2 is positive 2. So in the first two terms, we have 2n in common. If I pull that out, I'm left with n minus 2 minus 1 times n. I made a minor error here. So this has to be plus. So plus 1, we keep it as n minus 2 here. Sorry about that. And we have n minus 2 equals 0. So we have a common factor, and that common factor is n minus 2. If I pull n minus 2 out, I'm left with 2n plus 1. We just have to set each factor equal to 0 and solve for x, or n in this case. N minus 2 equals 0, therefore n is 2. 2n plus 1 equals 0, which would imply 2n is equal to -1, which would imply n is -1/2. So the next one, clearly the right-hand side is not 0. So what we have to do is make sure that the right-hand side is 0. How do we do that? Distribute, simplify. So distribute the n, we have 3n plus n squared equals n squared plus 4n. And let me move the n squared to the other side. We have 3n is equal to n squared minus n squared plus 4n, which would mean 3n is equal to 4n. N gets cancelled, and we have 3 equals 4. In this universe, 3 cannot equal 4. This is not possible. That could mean only one thing. There is no solution to the given equation because the equation is not proper. So the answer to that question is no solution. So here we have a cubic polynomial, but everything is nicely factored for us. So we just have factor multiplied by factor multiplied by factor. And it equals 0, so either one of them 0 or all of them are 0. So all we have to do is set the factors equal to 0 and solve for x, which would mean x plus 2 equals 0, x minus 7 equals 0, 3x minus 8 equals 0. In the first factor, move that 2 to the other side, x would be -2. Move the 7 to the other side, or negative 7 to the other side, x would be positive 7. Move the 8 to the other side, we have 3x equals 8. Divide by 3 on both sides, x is equal to 8 over 3. And if we have a third degree polynomial, we would have 3 solutions. So typically, the number of factors would equal to the number of solutions. So the first thing to notice is this factor 3x plus 1 is fine, but that is a special product, and it is of the form a squared minus 5 squared, and 5 squared is simply b squared. And we know that a squared minus b squared is simply a plus b, so x plus 5 times a minus b, x minus 5. So I could write that entire equation as x plus 5 times x minus 5 times 3x plus 1 equals 0. I have 3 factors, so all I have to do is set each factor equal to 0 and solve for x. So x plus 5 equals 0, x minus 5 equals 0, 3x plus 1 equals 0. Move the 5 to the other side, we have negative 5. Move the negative 5 to the other side, we have positive 5. Move the 1 to the other side, we have 3x equals negative 1, which would imply x is negative 1 over 3. So the answers are negative 5, 5, and negative 1 over 3.